All right, so today's session, the title is DevOps CI/CD with a Microsoft SQL Server 2017. There's two hidden words in Docker container and the Kubernetes cluster, right? So in the detail, we mentioned it, but in the title, somehow it was not listed. So we're going to start that. So before we start, let's do some pre-check, because we are going to talk about Docker container and Kubernetes. I'd like to know some of the information from you. Did you attend yesterday's Travis Wright's session about SQL Server production on the Docker OpenShift, that session? All right, so you guys have some basic in there, okay? So second question, have you used the SQL Server 2017 on the Linux or Docker before this session? All right, not many, good. And how about the Kubernetes, the container-centric clusters and orchestrations? All right. And do you or your company practice CI/CD for database itself, database development? Okay. All right, thank you very much. So no worries. We are going to cover the concepts and basics first. So for Docker and the Kubernetes and the container-centric orchestration. And then I'll talk about the database as a component of your application, what it actually means. And Michael will talk about the CI/CD of the database in action. And persistent storage for database that Michael will cover. Because in a Docker container and a Kubernetes world, it is what is most important is being able to persist database, right? We are talking everything in the database context here. So the persistent story is very important. So those are kind of 4 points that you're going to go through with me. All right. So far, probably you are very familiar with this slide, right? One of the biggest enhancement, the biggest change in SQL Server 2017 release is that now we support the Linux and Windows, right? And then we have a third box. It's a Docker. What is that, right? Some may think that, OK, SQL Server only runs on Linux and Windows. And what about the developers using Mac OS laptop, right? So Docker is a workaround for those Mac OS, the developers who's using a Mac OS. That could be one, like if somebody answered the question that way, then maybe 10% is right. Then what really Docker means? Let's go through that in this session. So before we go there, let's check the statement saying that SQL Server is a component of your application, right? As of today, we have app and database. Simple. But that's not all, right? We have dependencies like drivers, .NET drivers, ODBC drivers. If you're using Python, then there's Python versions. Your application needs those drivers and other stuff that make the application run and work, and also connect to the database. Database side, there's a SQL Server. And each of them has its own versions, right? All that together, tightly coupled, and make as my application version 1.0. Time goes by, and I have version 1.5 with all the different versions for each of those components. That's our application, right? Then where do you run the SQL Server in that world? Local dev machine, and share the dev server environment, CI/CD environment, pre-production, and the UAT environment, and production, many places, right? And what is the common problem? If you're from like an engineering division or a developer division, probably you have something called the engineering cookbook for new members, new team members. First few pages are how to set up your tools, how to set up your SQL Server, what is the version that you have to use, all that, right? And whenever you file a bug report to SQL Server, our team, or any Microsoft team, or within yourself, what is the common template? What is OS version, right? What is SQL Server version that you're using? What drivers you have installed on your machine, right? And commonly what happens is that there's a bug. And you say, there's a bug. And then developer says, but it works fine on my machine, right? We encounter that issue every single day. And in that uncertain world, we talk about CI/CD automation. Can I really trust it? Do I still have to do all hands review, right? After the bits and pieces go through the CI/CD pipeline, how can I trust it? Does container solve the problem or not? Right? Let's check it out. So, what is Docker and what is container? One of the most frequently asked questions to us whenever we talk about Docker. Docker is not Microsoft product. It's open source, and there is a Docker.com who's actually a large community and a company who's supporting that one.
Probably just a couple minutes.
Key question is, hey, what's the difference between virtual machine and container? Is it the same or not, right? Look at the diagram on the left. That's a virtual machine. You have infrastructure. That is just your machine, your PC itself, right? And on top of that, you have probably run OS, Windows, Mac, or Linux. You run that. In a virtual machine, there is a hypervisor that runs guest OSs. Now, here important is that when you have a virtual machine and a guest OSs, you usually run multiple applications on that guest OSs. I have a Linux or Windows VM running. Then I run SQL Server on that. I install SSMS on that. A bunch of applications. And that virtual machine is good for that, right? When you go to a Docker side, what happens is that it starts the same infrastructure, your machine, and it has an OS, host OS. And it runs Docker engine. And on top of that, it runs application and all that dependency, encapsulated it as a container, okay? Big difference is that there's no guest OS layer. The containers uses host OS kernel and resources directly. They do resource governing and the resource the isolation of the app process, all that, so that it allows you to do that, okay? The key characteristic of here is that a Docker engine abstracts away OS, storage, networking very well. So that is one very important characteristic. And the images are immutable. In the virtual machine, you build the images and then you use it as the guest OS image. In the container world, that concept is the same. You build the image, and then you spin up the container. But the images in here, it is immutable. Now, let me explain what it really means. One of the biggest benefit coming from that is that it's portable. It's the OS-specific, network-specific, storage-specific natures are abstracted away, and it is the images are immutable. If you build your application on Docker on your dev machine, then it runs on your test and production environment that runs on top of Docker engine. That's a portability, predictability, right? So there is the concept that somebody has to install your software after you spin up the container. Container itself abstracts all that together as an app and run it. And here the biggest difference between the virtual machine as well is that container is good for running an app, a process, single process, instead of running multiple processes, okay? So Docker is kind of optimized in that scenario. Now look at that, the concept. It's a fast to deploy because there is no bootstrapping. It's immutable. It's just a copy and write and start your container instead of boot up your OS and then run some installation configuration kind of stuff. And then it's easy to scale, and then it is easy to put it in a CI/CD because all that process is declarative. You build, push, deploy those image, and then spin up the container. Is all done based on declarative way. I'm going to show you all the details. Just to keep that in mind. Okay, those are kind of benefits, right? Okay, so I trust you. So let's move on. But if you want to understand more, there are 2 articles. I have read a bunch of articles to summarize this slide. And these 2 articles actually nail it really nicely. So if you're interested in, what Eric really means, what why he's saying the portable and predictable for what? What technological region? What is there? Then you can read this one, and then you will get that one. So the key benefit is portable and predictable. Just to keep that in mind, and then let's go. So, as I mentioned, when you are using Docker, you need to have an image. This is a spec, very simple spec to build an image. So we are building a Docker image that has a SQL Server running in it. So first one, you don't have to understand all this detail here. Just to look at the pattern. First, you need to have a baseline image. Here, the baseline image is the SQL Server image. It can be any OS image, empty OS image, or Alpine OS image, or Ubuntu image, or the OS image, Red Hat image. You need to have a bottom line, the baseline image to start with. And then what you need to do is just adding more layers on top of it. Okay? For me, I wanted to have a backup file in my image and restore script in my image. So I just added it. You may have a different need. You need to install some other the libraries in that. Then you can install it. It's just adding layers. Okay? And then you define the command. So when container starts, after it finishes all the bootstrapping, at the last, it runs the command, right? You're specifying a command. If you don't specify a command, then what happens is the Docker container starts and then terminates right away. Or starts, if the command is not like a service, a daemon kind of the command, then it executes it and terminates itself. In this case, I'm running a SQL Server, so it boot up and then run SQL Server. As long as the SQL Server process is alive in the container stays. Okay? Now, just to remember that this is the pattern. You need to have a Docker file to build an image. Okay? There's a different ways, but this is a kind of a common way that you can go. And how you build, it's just running Docker build. Just remember the command, the Docker build, and then publishing the image to the repository is Docker push. So you're gonna just keep using these two commands with this the pattern of Docker file on and on and on, whichever job you're doing along with Docker. Okay. So I just mentioned the pushing it or publishing it to a Docker registry or Docker repository, right? So there is a huge ecosystem of ready-to-use images in Docker Hub. Docker Hub is a public repository that the companies, official companies like Microsoft or the Ubuntu, Red Hat, they kind of publish their official images so that the people can download it, use it publicly. Okay, and then a person like me, individually, I can have my own account and then publish things in a public matter, or I can have my private repository folder there and then publish my stuff there if I don't want to share. So repository is like a GitHub. It's kind of very, very similar concept, right? Just that the images are published so that the people can access it and download it and use it and use it as their baseline image. Azure also has a version of Azure, the Docker registry. It's called the Azure Container Registry. Okay, so if you want to just build a team environment within your, let's say, project team, and you don't want to share it outside of the world, then Azure Container Registry is a good one that you can just create a service in Azure and use it and publish your Docker images whenever it is built. Or you can actually host your own the repository, registry service, using Docker registry image. It's also an image. You can spin up a container that acts like Azure Container Registry or Docker Hub out there, and then you can just share it with your friends or your team members. That's all what you can do. Okay? So those are kind of big blocks in the Docker container. And then what is the container orchestration, right? So if you run a Docker engine on your, let's say, laptop or your PC and deploy the containers there and run it, it's like a single machine perspective, okay? But if you want to kind of build like a scale out the cluster like the environment to build a very high density environment, then you need more than one machine, right? It's just same concept of that why you need a cluster in your data center and your production environment. So even architecture is very similar. It has a master node that provides an API and scheduling, all the controls that you also communicate through each tool that is called the kube control. If it is a Kubernetes, it's on top. And you have nodes. Nodes are worker nodes. And if you take a look at each node, there is a light blue box, which is Docker engine, right? It's like your own laptop. Each of those nodes is each of those machines and the VMs. Yes, sir? Okay. So, so you can, it's very, very easy if you understand it that way. Now, what happens is that, let's say you want to deploy your container, which is, let's say, web server container. That runs the web, right? And the one can probably do certain amount of workload, but you have many, many users, so you want to load balance it and scale out your web server. Then you probably would have, let's say, 2 or 3 or 4 the web server containers that runs your web applications, right? Then you want to kind of automatically deploy it into multiple nodes, worker nodes or machine, and then you want to kind of make sure that it's, the scaling is automatically done, and then the resilience is done. If one container dies, then automatically restart it. All that kind of orchestration is needed. Otherwise, you have to do it manually using Docker engine on each machine by yourself, right? So the Kubernetes, OpenShift, Mesosphere, Docker Swarm is providing you a solution to automatically deploy, scale, and schedule, keep the resiliency, redundancy of your containers, right? And it checks its nodes' health, like the storage consumption, CPU availability, memory availability, and it automatically kind of schedule the location of your container for you, right? That means you can pack up many more containers per node to maximize your resource utilization. As I mentioned, VM is like a virtualizing the OS layer. Container is like a virtualizing your application process, right? That's probably an easy way to think about what high density in this case. So how many VMs you can run on your laptop? How many apps you can run on your laptop, right? There's a difference. So container can go much higher density with this, given the same amount of resource. Okay? The good thing is that the Kubernetes or these cluster solution tools run on local host. Like I'm going to use my laptop to run a single node cluster today to do demo. And it can run on the Metal server or VM server. Or it can run on the cloud providers like Azure Container Service. And the Google has their version of container orchestration service as well. Amazon has one. So there is a cloud version of that one too. So I will also tackle down that in the later slide. Okay, so as I mentioned, the Docker file was a kind of a declarative. When it comes to the cluster side, it's also kind of declarative. So just look at the pattern. Number one is defining, let's say, control. How are you going to control your container? When it comes to cluster, container is wrapped with a pod. So there's one more layer. It has like its own IP address and kind of stuff. But just remember that container, if you run, usually pod runs the container, but the common practice that you run a pod, a single container in a pod, okay? So container equals pod. You can just start with that. Then the declaration of the control is that you want to have a multiple replicas of those pod or not. It's kind of a defining. A deployment is starting with one replica. If you can define, okay, I want to have 3 replicas of same pod, then it deploys 3. So you just define it that way, okay? And then you define then what is the container that I want to run in that pod, okay? So in the number 2 is defining what is the image. You just say it can be a SQL Server image. This one is my image. I have account in Docker Hub, Eric S. Kang, and I have created a unit test DB image by myself using the Docker file and pushed it there. So I'm just declaring that I'm going to use that image, okay? And then the service is defining how you're going to expose your container to other containers or to external users, right? So it's a simple, like I want to use a port number 1433 for the container, and just defining it there, okay? And the other one is on the right side. This one is a application declaration, right? Same thing. In this case, I'm going to call it as a web app, as a name of the container. And the image is Eric S. Kang /web app, latest version. That's the image that I'm going to use to spin up the container. And defining the service, the container exposes port number 3000 as it's a port number defined by the web server itself. But I'm going to expose port 80 when it goes to outside of that, right? So port 80, whenever there is incoming the traffic at port 80, it maps to the port number 3000. That's basically what I'm going to map. So if you run just a couple of the sample, then you will get it. Just look at the pattern for now, okay? You don't have to, if you haven't done this, the Kubernetes spec authoring, you don't have to remember all this. Just to look at the pattern. You define the pod, a container, and then you define how you want to expose it. That's always the pattern. Whatever you do, you're going to follow the same pattern. And deploying it into the cluster is just running kube control. That is the command tool. And a command called apply -f and your spec name. That's it. So if you want to remove it from your cluster, you say delete, kube control delete -f and the same spec name. Then it will just go and delete everything. Okay? So before we go into the demo, I will show you a real-world example. If you joined the Travis session yesterday, probably you have seen this one. SQL Server engineering team is actually running entire test process using Kubernetes. Okay? And we use automated build process. So here, whenever we say automated build process, we are building SQL Server image, right? And then that gets deployed to Kubernetes cluster. We are deploying it to 700 containers, right? Coming from the SQL Server Linux image, we spin up 700 images, and we run the test once per day. If we don't do that, and then we run it parallel computing, parallel testing. Otherwise, it takes a really long time to run all the test cases. But we can just start the 700 container and then doing the parallel testing, so we can do it really quickly. Okay, that is a real-world example. And we are using 150 VMs. That has a 128 gigabyte and the 8 core per VM. And that's what we are doing. And we use we run the 20 SQL Server containers. SQL Server image and container is a rather large size container. And we use 20 of them per VM. So it makes a high density the cluster. So that's basically the real world example. Okay. So just remember, okay, Docker file, declarative. I need to have image. Okay, Docker build, Docker push. That's a way to push, build and push. When we deploy the Kubernetes hub, I need to define the Kubernetes spec, just the declaring the container and how I want to expose it. And then using kube control apply, I can deploy it. Just remember that level for now. And let's look at the CI/CD perspective in that matter. When we talk about the database in CI/CD, we have roughly production environment, development environment, In the middle, we have pre-production. And in the data plane perspective, we have production data and the sanitized data. So when data moves from production to dev and test environment, we need to sanitize it. Like if you have your customer's social security number, credit card information, you don't want to pass it all the way down to all the dev and test environment, right? So, so those are kind of the sanitized data perspective. So what happened in a cycle in terms of DevOps and CI/CD? When there's a new sprint starts, you create a dev and test environments, right? And sanitize it and pass it to dev and test. And dev and test team consumes that environment and make a change, bug fixes, and enhance the feature, and check in. Whenever you check in, build occurs, run test, right? You continue it until you're satisfied with all the changes and test result, and then declare, okay, sprint is finishing. Now, you're building pre-production environment, right? And then you run the pre-production level of test. When it is kind of passed through, and there is authority to approve the production deployment, then it continues. So you repeat this cycle, okay? That's a generic CI/CD pipeline with the data. Combining that with the Docker and the Kubernetes world, I'm repeating because it's a pattern. Because it's a pattern, I'm repeating, and I'd like you to remember the pattern when you go and practice this one. Okay, so there's 5 easy steps. Again, define your container. As I mentioned, one application process per container. A container is defined with image, Docker image. A Docker image is declaratively defined and built using Docker file. Okay? So, in our case, I have a SQL Server, one container, okay. I need to have a web application, one container. I need to have a test and test running process, another container. So I have 3 containers. Then just to define it, build it, and push it into a repository, public or private, or your team's repository. And then define a spec for your the cluster, container-centric cluster deployment, okay? And deploy. Now, because we are dealing with a database, you need to have persistent storage. One of the key characteristics of the Docker container is that Docker container the image is immutable, and you're not modifying the image itself. So it starts, and if it dies, then all the data inside of it goes away along with it. Okay? Now we are database people. If you create your database file within the container, then when container is killed, then your database file will be removed along with it, right? So to exercise database, you need to have a persistent storage. Michael is expert on that one. That's why we invited Michael to talk about that in this session. So keep that in mind. And there are cases that you don't need persistent storage for database, like a unit test. Unit test, you don't need the real, the user data. What you can do is that you sanitize it, reduce the size to 4 gigabytes database to, let's say, 80 megabytes. And you can just run it inside of a container. And for testing purpose, you don't have to persist the result of test into that database and then keep it, right? So there is a stateless use of database for testing or some of the development. But most of the cases, you need the persistent storage, right? So that's a pattern. Now, one more pattern. Now, combining that knowledge into something more tangible. So when we talk about the CI/CD, then what are the components? We have source control, all the Docker files and the Kubernetes specs or your source code and test, everything. Keep it in the source control, okay? It defines your team. Nowadays, most of projects uses the source control, right? Nobody uses the OneDrive for project file source code, storage, right? so GitHub, VSTS supports like other type of source control as well. And there is that. And the VSTS is like a control tower for your CI/CD workflow and automation. What happens is that when there's a change occurs in source control, VSTS monitors your source control repository, and when there is the change detected, then VSTS triggers a workflow saying that, okay, VSTS agent, which can be Windows machine and Linux machine, now there is a change happened, pull down the source code, and then run what is defined as your agent job, build job that I define. So there is a very easy the templates that you can do, and Michael will go through that one in detail in the later stage. But just understand it that way. Then in the Docker container-based CI/CD world, what happens is that agent builds your image. Because you have a Docker file, and you know what is the command to build it. Agent can just grab the Docker file from the source control and run Docker build. And Docker publish to repository. Now we have a SQL Server image. Now with my backup file and backup the script in it, and the web application, test runner, and 3 images are created, right? When the image creation is successfully finished, VSTS monitors that process and then triggers the next step. Okay, now then deploy it. That is a kube control apply, right? And then it gets deployed to dev and test the cluster. Okay? And there you can run, let's say, test and verify, right? And within your sprint cycle, it continues automatically, right? It can be built like multiple times a day, or you can, if it is too much for you, then you can kind of set like a daily build, do it daily basis, right? You can set the cadence like that. And once dev and test side is all done, then you have a workflow, okay? Now it's time to deploy it into production, right? It can be fully manual, like a click to deploy from in your workflow. You can, in VSTS, you can set that workflow, and somebody has to actually approve it. You can set all those workflow like any other workflow engine. And then, or you can just monitor the result of test and then dev and test environment. If it successfully finishes, let's say, a test run that as a exit condition, then you can set, then automatically deploy it into production. Now, we talked about Docker image is portable and predictable, right? If it is successfully run, on DevBox, then it will run on the test cluster, right? If test cluster successfully finishes all the tests and runs correctly, it will run on your production, right? That is, to me, a key value. Before, we couldn't guarantee that, right? Let's take a look at demo scenario. Okay, this is a kind of I'm using this demo scenario for multiple sessions, not only for Ignite or others. I like this one. Okay, so instead of doing the sprint-based the demo, let's make it a little more urgent. So I'm a dev. I'm junior dev. Michael is a principal dev. Okay, and he has worked on this project for a long time. So he has set up a Docker image creation, all that system, right? I'm a new guy. And you guys are order fulfillment team member, like a delivery fulfillment, order fulfillment, sorry, the members. What happened is that customers are, we are wide world importers online sales company, right? And what's happening now is that customers are creating order, and they pay using their credit card. And they never get their product. You guys, what happened is that when you look at the order, there is no product information. It's missing. There's an order number and the product name, the customer name, but there is no product information. So as an order fulfillment team, you cannot complete your job, and customers are now calling you guys, right? Hey, where's my order? Right? That's the situation. So my job is to fix it as soon as possible. I'm a new guy. So what happens? 24-hour pass, and you call me. Hey, Eric, where's the fix? I'm setting up SQL Server. All right? I'm installing my test framework. It uses Ruby. And the engineering cookbook is outdated. So I followed it, but it doesn't work. All right? Give me some little more time. 48 hours. You call me. Now I finally installed the SQL Server. All right? Is it familiar to you? All right? And you're getting called from customers every single minute. Okay. Now, let me show you what we can do in that situation. Okay. So as a dev, Michael told me, hey, okay, you're a new junior dev. What you need to do is that you need to have an environment, a Docker environment or Kubernetes cluster environment. That is a kind of a very almost the same as a production and test environment. There's a Minikube that is a single node cluster version of Kubernetes. Go install that. Okay? So you can just go to this website and follow installation steps. It's very simple. It's like a 4-step installation. And you go there, install that. And Michael has produced web application image. If I go to the Docker Hub, these are the Docker file that defines the web application. So as I say, it starts from a baseline image, which is Alpine distro of a Linux version, and then just to copy over the Node.js files in there and build it, right? Likewise, he has done the test framework runner. So it has a test cases, and then it has a process to run tests against the database. And it has he has done a unit test database creation. So in this case, there's a SQL Server running with a unit test DB sanitized data inside of it, and he just packaged it up as a one image, right? So, and he told me that, okay, just to go to project site, let me show you. This is one of the GitHub project, and says, just run this one. This is the spec. Okay, so let me show you. Oh, sorry, too much. Let me do it one more time. With more. Okay, so this spec defines, okay, we need the SQL Server, right? And we're going to deploy the SQL Server using the image that we just saw, right? And then port number 1433, that's any the DBA would know. Anybody who's using SQL Server know 1433 is the default port. And then it goes with test framework, install that, and it's exposing a service, likewise a web server, so it's just a REST API kind of stuff. So at port 8000, and then deploy web application. So after you fix your code, please check if application works, all right? All that together. So let's do it. Kube control, apply, -f, and the spec. Oh, I didn't tell you. I already installed the Minikube. I think I didn't start it. Sorry, this is the demo glitch. I was supposed to start this Minikube before starting this demo. I forgot. So my demo time will be increased like 20 more seconds, maybe. So starting the single node cluster usually takes less than 30 seconds, I believe. And while we are waiting for it starts, what it does is that you first to go and then install VirtualBox, which is the Oracle version of the virtual machine tool, right? And then using that one, you just install that and install Minikube and run Minikube start. Then it automatically provisions all the clusters and components for you and starts it. So that's what it takes. So now it is started. So apply -f. Let's do it. Now it is done. Okay? That's what it takes. Let me go to Minikube, dashboard. Then you can see things in web page. Let me do it one more time. All right. So the Kubernetes has a dashboard. So if you go here, and I go to my namespace SQL DevOps, then you see that database, SQL Server running, web application, and test runner all works. And 3 pods are deployed. So this is a now new developer's life. Okay, much simpler. And even though the engineering cookbook is outdated, I know that always my dev and test environment is up to date, and it is on par with my test and production environment, right? So that is the value. We've been talking with the customers who's actually using it, and one common thing that they say is that Docker, Kubernetes, for dev and test, fantastic. It just increases the productivity like this. No comparison. So take a look at and try that at least in your dev and test environment and start seeing the value. So let's go back. As I mentioned, my test API is running here. The Kubernetes is I just assigned the name Kubernetes to IP address of my local Minikube. So this is a test application, and let's run it. Everything is fresh, so there is no SQL Server query plan yet for any of these queries, so it takes a little bit longer at the first one. Okay, so done. So without installing anything, I could run the database unit test, and it tells me what is failing in our test, right? So there is a store procedure that is failing, and then for what happened is that the incorrect product ID was inserted to this store procedure, but the store procedure didn't raise any error. So that's why the application side, it went through, but there was no record recorded in the database side. And then that's why you guys are getting the call from customers. Okay, so now I know where to go and what to fix. So this is my database project. So let me start one. I'm starting a Visual Studio Code, and here, what I did was that I fixed the bug by adding this 2 line, right? I'm not going to, it's not to do demo how to fix it, just to say, after spending like 30 minutes, I fixed it, okay? And the fix, how we do it in terms of migration script-based database version change is that you have a list of the changes that defines certain version of your database, okay? And in DB project, that is what Michael also did. He has a small Python application. It connects the database, checks the database version, and compare it to the source control version. And it just change the version by executing the change scripts against the database in sequence, okay? So it's kind of common practice for what you guys are doing when you do a database version change, right? If you do it. That's the change. Then, so now we have fixed the bug within, let's say, 30 minutes instead of 48 hours, all the waiting time and all that kind of stuff. So now we have the fix. Okay. Let's go back to our slide. Oh, sorry. Now, it is time to change the change, deploy the change, database change, right? If it is an application, it's simple. You just build a new image and then replace your application image with new one, right? But database is different. As I mentioned, in a container, what it runs is SQL Server instance, is correct version of a SQL Server instance with the correct version of Apache is installed, but database file is outside of the container, right? And also for the security region, you're not going to allow people to directly connect your database from some internet. It's behind the firewall, right? Behind the firewall network within your cluster. So how are you going to deliver the changes, right? The solution is use a job. So in the Kubernetes or any container-centric orchestration, they have a definition of a job. There is a two types of job. One is a job to complete. Likewise, the deploying the database change, creating a database. Those are something that you want to execute and complete and finish, right? So job to complete runs the job, and once it is complete, then it terminates its process, okay? There's another type of job. It's a cron job. So if you want to do scheduled backup on a SQL database running within the Kubernetes cluster, you probably would like to check cron job, okay? And let's say every 24 hours, do full backup. It's just simple. What we are doing is we run a script, right? Backup script. And just using cron, you just run it every 24 hours. And when it comes to the Kubernetes and Docker world, you are building a Docker image that runs the job in a container, right? That's only change. It is not that hard. So in next demo, I will show you what it really means, okay? Okay, so let's go back to our the project. I'll open it. This one is the database change job image definition. So it's a pattern, right? Starting with image that has a SQL command in. It's just nothing's there, just the bare minimum Linux Ubuntu OS and SQL command installed on top of it. That's baseline, okay? And because Michael made it as a Python, I added Python dependencies in that image, right? Just installing it into the image while it's building, and then copy over all this project into that image so we can access it. All right, so for that, Docker build, we just run Docker build and Docker push. Let's just run it. All right, that's it. So our new image is published to here. Okay? Then once it is published, then anybody can consume it within your team member. That's the concept, and that's the pattern that we are repeating here. Okay? So now let's run it as a job. So I have defined the two jobs here. Let me show you database migration job. Using that image that we just created, DB jobs migration, we are creating a container as a job type, okay? And we add the one command, start the container and run this command. That is, run this migration runner.python script, okay? Apply -f, let's run it. Okay, that's it. So now it is deployed to your cluster, and it will do its job. So let's go to our dashboard, which is here. Job is created within a few, maybe it didn't take a second. Okay, the job is already complete. If I go and take a look at log, all right, so it executed all the database, the version changes, and then now it sets the version of the database to 1.1.0. That has a fix for you. Same thing can be applied to running a backup, right? So this is the case. So I have an image that has SQL command and the script file that does a backup of all databases in the connected server. And I just define it as a cron job. And I specify the interval. Every 24 hours, run this job. Then it spin up a container, and then they make a backup, and then it goes away. 24 hours later, it starts. So it's like what SQL agent does, right? All right. All right, so I repeated the same thing on and on and on, just to let you know there's a pattern, right? You guys see the pattern here? It's a simple pattern. And just defining those Docker file and the Kubernetes, if you just practice like a couple times, then you will just get it. It's just a set the content, the set template. You just repeat the same thing on and on and on. But what is important is the pattern. It's not that complex, okay? Now, I showed you everything running in the local machine. Do you have enough time, by the way? Oh, sorry, yeah, I ran over time. So this is the last slide. As I mentioned, Azure Container Service has the Kubernetes running. It is really simple to deploy. Now, in the you log in, and just to create an Azure group, and run the middle part. That's it. You just change the name to your name, your cluster name, and set the agent count to 2, to whatever number you want. The agent count is actually the number of nodes. So if you're running really large workload, then you can set it like a 10. If you just want to try it just the once, then it's number 1, right? That's it. And then go out for coffee. After you finish like a 12 hours coffee, then your cluster will be up and running. And then what we just saw in our demo, if you just the cube apply to that cluster, it works exactly the same. Okay? So I'm just showing that simple command is creating this complex stuff in there. You don't have to worry about it. You don't have to understand what it does. Okay? And it's so easy to provision, and it's easy to scale out and up. The agent node is a Azure VM. But you can scale up to a different pricing tier if you need much more power. You can simply add more nodes if you want. The scale up and scale out is easy. And easy to monitor, like this. And then it supports as large as a 140 gig and a 20-core node. Sorry, Mike. So now, the last part is important for database guys, persistent storage. So Michael will spend all 20 minutes. Okay? 20 minutes. Yeah, 20 minutes. Sorry. And then go through that. So please remember the persistent storage is important for database. Yep.
Excellent. Thank you, Eric. Can you guys hear me? No? Is it on?
Yeah.
Now it's on. Now you can hear me. Excellent. All right. So storage for databases is pretty important because what Eric has showed you is mostly ephemeral type workloads, unit tests, and so forth, where you can kind of spin up and run your transient workload and kind of throw it away. Excuse me. So when it comes to persistent storage for containers, there are a number of things that we kind of need to look at. And Docker is like the Docker engine itself, right? And then you have the orchestrator for Docker, which is Docker Swarm. Kubernetes that Eric has talked about is another orchestration layer, and you also have Mesos, which is an Apache project. And what's also being mentioned with Mesos is Mesosphere, which is a company who's productized Mesos and building this DCOS. And they all have different implementations when it comes to how to handle storage. And on the Docker side, there's like a plugin framework, both available for Windows and Linux. And on the Kubernetes side, you can do something called a flex volume plugin. You can also do an in-tree storage plugin, which is not allowed from Kubernetes 1.7 and onwards, or 1.8 and onwards. So they're waiting for a new kind of persistent storage framework to materialize. But what we have built from the HP side of things is that we have a flex volume driver for our storage products. And looking at Mesos and the Marathon scheduler, they have something called a Docker volume driver isolator, right? And if you kind of look at the least common denominator between all these orchestration frameworks is that if you can plug into the Docker volume API, as we've done with our flex volume driver, you're pretty much good to go to be able to provision storage to all these orchestration frameworks. And it looks different on Windows and what it does on Linux. On Linux, you have a Unix socket that you talk to, which has a REST API and so forth. On the Windows side, you simply have a daemon running, which is listening to a secure port. And this is kind of where our product come in, where we have a Nimble Storage Docker Volume plugin. We have a Docker Volume plugin for 3PAR. There's also one for Store Virtual. And I'm going to talk most about the Nimble Storage plugin, and that's what I'm going to show with my demo and so forth. The Docker Volume API is sort of, there's a lot of keywords that you can kind of apply to that is specific for your particular driver, right? You can specify the size and where you want to place it and so forth. And this is a lot of small text here, but I kind of want to draw the bigger picture of what data services that you can provide into these frameworks. So if you look at the data services side, you can provide QoS limits, define performance policies, and so forth. We have the ability to do zero-copy clones of volumes. We also have a very robust platform with low latency and 6.9 of measured uptime. And this is all available to containers as well. From the data protection side of things is that it's very important that your data is backed up, it's replicated, you got snapshots. Some requirements are that the storage is encrypted at rest and so forth. You also want to have a very efficient storage platform when it comes to persistent storage. You want to have all the latest data reduction features, zero pattern elimination, deduplication, compression, thin provisioning, and so forth. So how do we enable this for Kubernetes? And Eric talked a lot about what the different specs looks like and so forth. So I'm just going to draw up a sample spec here, what this could look like inside a Kubernetes pod spec. So we give the volume a name, in this case, a MS SQL data volume. We call our flex volume driver, HB/Nimble. If you're working with a different vendor, that will be different. And after that, you have a set of options that you specify. It's like, what Docker volume name do you want? You give it a short description. You can import the volume as a clone, for instance. If you're using this for CI/CD, you can do once you're done with this workload, you can destroy it. Once you bring down the kubelet and so forth, be able to create a snapshot, give it a snapshot a name. You want to be able to govern the performance on this volume that you provision for this purpose to not disturb your production environment. And these are all Nimble storage specific parameters, right? So depending on the Docker volume driver that you're using, you will have a set of different options. So when we talk about containers, we talk a lot about building, shipping, testing, and so forth, right? And I have a scenario here that I'm going to walk through in my demo environment where you essentially have a developer who has a lot of ideas that are done in his corner, and he's consuming a lot of services, right? Software as a service. So he's using the Azure Container Registry, he's using Visual Studio Team Services, and on-prem, he has his production environment. It's running container as a service, infrastructure as a service. He has a bunch of users that are consuming his application. The application I'm going to demo here today is called XWiki. It's an enterprise wiki system that leverages SQL Server as the backend database. You also have a test and stage environment that you test new features, test new images, and so forth. And also on-prem, you have the Visual Studio Team Services agent running, so your SaaS services integrate with what you have on-prem. in this particular example, I'm using Red Hat OpenShift. I'm using persistent volumes from a Nimble storage array. And essentially, what happens is that the user does a git commit to some work, and he pushes that to his Git repository on visualstudio.com. And what happens is that a container gets built, shipped, and run in the test environment. Now, when that happens, a clone of your production environment gets imported into the test environment, right? And there's a bunch of tests running on that volume to make sure that the application works, and it brings up the application. And once you're ready to deploy this to production, you do a git checkout master, you merge it with your work in progress branch, and you push that to master, and then you have a continuous deployment manifest that essentially deploys that production application into your production environment. So I'm going to run a quick demo how this works. Let me see how I'm doing on time here. So what I have here is the XWiki demo. I've set that up on visualstudio.com. I have a build workflow set up. I'm going to show you that real quick, what that looks like. So I have both a CI workflow and a continuous deployment CD workflow. I'm just going to do the CI demo at this point. We do an edit here, so kind of just to illustrate the different steps that are involved here. So I'm using the Docker features that are provided by visualstudio.com. So I basically build an image, I push that image to Azure Container Registry. I have a secret in here to make sure that my passwords aren't stored anywhere in plain text. In my source code repository, I have the password saved in visualstudio.com. I run an Ansible playbook, and that playbook basically deploys the application and brings up the application, and it communicates with my OpenShift cluster. Once that image gets brought up, it has a short test. It just tests a URL within the application. It will then tag that image and push that image to the repository, and that will then mark that image as a production image. Looking at the OpenShift container platforms, I have one test environment and one production environment. So inspecting the production environment here, so this is kind of the default dashboard for my prod app. I have one custom image, which we can see is hosted on the Azure Container Registry. I have a custom registry stored there. You can also see that I'm using the stock SQL Server image from Microsoft, from Docker Hub. Inspecting these pods a little bit deeper, you can see that in the SQL Server case here, it has a persistent volume attached to it. If I kind of look at the YAML spec of this particular application, we can see that we're utilizing a flex volume, HP/Nimble, and it has a certain characteristics. It's encrypted, it's 100 gigabytes and so forth, and it has a performance policy of SQL Server attached to it. So this actually maps to an actual volume. So I'm just going to show real quick what that looks like on our storage array. So what you see here is the interface from our array software that is running on the array. I'm going to go in and manage my data storage here and just show you real quick. I put these volumes in a prod folder, and you can here see the 100 gig SQL Server volume that is hosted on my array. The wiki application itself is very simple, so I'm just going to do a edit here to kind of show you that. No, I need to log in. That this is an actual instance that will be cloned into a test environment. Let's see here, did I use a difficult password there? Yeah. Not now. So I have a test editor in there already, so I'm just gonna, this is another test edit at soft ignite, right? I'm going to save that. If I go back here to my test environment here, so I have the XWiki agent is the actual Visual Studio agent that I built, and it's running in Kubernetes as well, which is a good data point for you if you're looking at deploying this. That the Visual Studio Team Services agent is able to be containerized and run in Kubernetes as well. So in my test environment here, I already have an instance running, right? But the key thing here that what's going to happen is that this entire instance is going to be torn down, and it's going to be stood up again. But it's going to use the data from the actual production instance. So paying attention here is that we can see here that we're running build 138. If everything goes well, which I hope it does when you do live demos, is that we will have build 139. So I'm just going to jump out to my terminal here. What you can see here, I'm connected to my Git repository on visualstudio.com, and I'm going to do a very trivial edit to this repository. Oops, not going to type anything complicated today. There we go. There we go. And I now have a stage, a change stage. So I'm going to do a git commit. There we go. I'm going to push that to my work in progress branch. There we go, excellent. So what you will see, if we would go to the CI workflow here, for instance, in builds and releases, we can now see that that job is in progress. More interestingly, once this image gets built, is that we will see how this application here will be torn down and started up again. We're still using build 138, yes, we are. Yeah, so now we can see that the playbook that I have basically tears down the application, removes all the pods and so forth, and it's now on its way up again. Yeah, so there's some orphan pods that they take a few seconds before, oh, there they're gone. So now we kind of deployed a new application. So now we have a freshly cloned database, but we also have a freshly cloned instance of the XWiki application itself, because it has assets stored with the application that needs to be cloned as well. So now I'm running build 139. What is still happening in the build job here that is still in progress, I'm just going to log in here and see what's going on here. Something seems to be bogged down, but it's not actually, it's still retrying. So what gets generated here is a test URL. Once the application gets deployed, it takes some time to deploy because it's written in Java. It takes time to compile things. We all know that. And once that URL has been tested, this job will pass. And there we go, it passed. So after that has happened, it will tag that image that this image is all right, it works. And it will then push that image to the Azure Container Registry for the production instance to pick up if you choose to deploy this build to that particular instance. So kind of the ta-da moment here would be is that I copy this URL that I just tested, because each new test instance gets its own unique port number. And that is an important aspect of this, because you might have multiple developers doing multiple builds in parallel. So these resources need to be unique, such as the port number, the snapshot names that you take on your source volumes, and the volume names that you import for your particular application also need to be unique, so there won't be any collisions. So I'm going to go to my test. So this is the cloned instance. You're going to think I'm a new user because it's a new port number and all that. But I will go to my sandbox, and I should be able to see, oh, look at that. This is another test edit. So now I've actually cloned that entire application over to the test environment. And inspecting the different pods here in the test instance, I want to look at the YAML spec of this. So what actually happened here? So this spec gets auto-generated by my Ansible playbook. There's a lot of minutia behind that, but it will essentially send this request down to the flex volume driver that I want to create a new snapshot. I want to destroy this volume once it gets detached from my kubelet, so it kind of cleans up after it's done with the ephemeral application, so to speak. And this is also the source volume on my array that I want to clone, right? It's called msql-prod.kubernetes. I want to limit the IOPS and so forth that I talked about. And all these capabilities you're able to abstract from the array into your environment. And let's see, I want to cancel this. I want to go back. So, looking at the production volume here, right? I just want to show this real quick that the flex volume API itself within Kubernetes doesn't have any advanced features such as deleting a volume, right? And that kind of creates a lot of mess for people that do CI/CD because you want to be able to remove all the resources that you create. You want to be able to clean them up to not have any residual snapshots and so forth. So if you look at the volume that you have here, and you look at the data protection, so this is the snapshot list of your production environment. It only has one snapshot, and it's only the snapshot that it took for this particular volume. And the build 138 that was running previously has been deleted as well, and that is all being taken care of by the flex volume driver. So, and that was essentially everything I had. So I think we're going to step over to Q&A.
Sure. So let's go back to the slide. And
yeah, I just have a bunch of extra slides there. Just skip.
Before you go, if you go, then you're not going to see the reference. Let me just go. All right, so this is the reference. The last slide was talking about the production. There are many question marks. If you are interested in the licensing model, what is the BCDR HA, let me know, and then we can kind of chat about that one. And one thing that we want to say is that when VM started, the best practice was not running database in VM. Right, you remember that? Now everybody's running database in VM, right? The container, Kubernetes, this cluster is emerging technology. So there is still the same kind of a debate going on. Yeah, do you want to run database in right? But we strongly believe that container will go the path of VM eventually. Okay. All right. So all the demo that I showed is in the this link. I have made my project as a public source in the GitHub. So if you want to replay the same demo that I did today, then please go to this the demo project, and I put the README with the step-by-step what you can do. So just replay, then you will get it right away in a day, right? I spent many days to understand the concept, but what I repeated like 5 times maybe, that's a pattern. Just remember that. Then you're successful today. Thank you very much.